Gators. This is 3-1 reflections. I can draw and describe the reflection of a figure across a line of reflection. Let's take a look at rigid motion. Rigid motion is a transformation or a movement that preserves length and angle measure. A rigid motion maps lines to lines, rays to rays, and segments to segments. When performing rigid motion, we can refer to the original figure as the pre-image and the resulting figure as the image. This will be the pre-image. And the triangle has moved and it is now the image. This is the pre-image, and after it moves, this is the image. This is the pre-image, and this is the image. Notice that in all cases, when we moved it, the figure's lengths and angle measures all were the same. This is in contrast to something that is not rigid motion. This is an example of something that is not rigid motion. You can see that the angles have changed. This angle right here is a right angle, and this is no longer a right angle. Over here, it looks like this is a right angle and this is a right angle, but it doesn't look like this is the same size as this. So this and this are not the same size. So those would be examples of things that do not represent rigid motion. Segment bisector is also a perpendicular bisector. So this is the construction that I've taught you. I just want you to know that this is an example of a perpendicular bisector. It's making an angle and it's the midpoint, so that means this side and this side are going to be the same size. This is going to be important in our next concepts. We are going to be talking about reflections. And these two are examples of reflections. We're going to talk about it in terms of mathematics. And this is the mathematical description of a reflection. A reflection has to have a line of reflection, and each point will move. So this point B is what we call the pre-image. It doesn't have anything there. And it is going to go across the line of reflection to B prime, and this is called B prime. That is the image, and this is the pre-image. Now, same thing with C, and its reflection is over here. Notice that this is acting as the perpendicular bisector, and this is going to be the image. It's called C prime. If a point is on the line of a reflection, it doesn't move anywhere. It just stays put. So the only points that move are the points that are not on the line of reflection. Reflection is a rigid motion. It means it doesn't change its size or shape. The length and angle measures are preserved. Preserved means that are kept the same. This is also an example of the orientation, or the way the figure is facing is not preserved. So it's not facing in the same direction. Let's take a look at an example. This is R for reflection with respect to the x-axis. So we are going to reflect, and this is going to act as the perpendicular bisector between the points. So A is going to go across the other side to here, and remember this is acting as the perpendicular bisector. That point will be 2, 2. Let's do B. B is on the line of reflection, so it stays the same. H will go 1 unit to the line, 1 unit on the other side, H prime. So the H prime will be -3, +1. And then B will, there's another B, I think I meant to write F. F is -3, -3. And then F prime will be, it's going on the other side, 1, 2, 3, 1, 2, 3, and this will be F prime, and that'll be -3, 3. And if I go ahead and draw my figure, you can see that it looks like the angles and lengths have been preserved. Now, notice that when we did this problem, everything, the x's stayed the same. The x's all stayed the same. The only thing that changed were the y's. This y didn't change because it was on the line of reflection, but these y's changed. So this is the rule that happens when you do a reflection across the x-axis. The x's stay the same, the y's change sign. Let's go ahead and reflect across the x-axis one more time. So this is the x-axis right here. And we're going to go across the line, 2 units to the line, 2 units to the other side. And you notice the x stayed the same, it was the y that changed. The b is 1, 2, 3, 4, 1, 2, 3, 4 on the other side. And a is 2 to the line of reflection, 2 to the other side, a prime. Go ahead and join the points, and there we have our line of reflection. Let's do it again. See, this is across the x-axis. We're going to go 2 units to the line, 2 units on the other side, C prime. A is going to go 1 unit to the line of reflection, 1 unit on the other side, A prime. B is 1, 2, 3, 4 units to the line, 1, 2, 3, 4, 4 units on the other side, so that's B prime. And let me go ahead and make the triangle. And you can see the triangle is reflected and it preserves its angles and side measures. Let's talk about reflection with respect to the y-axis. So here's the y-axis. So we're going to take H and we're going to go 3 units and then 3 units to the other side, H prime. So H prime is going to be -3, 3. Notice that the x changed but the y didn't. C, we're going to go across 2 units, go to 2 units on the other side, that's C prime. And C prime, it looks like the x coordinate is -2, the y stayed the same. And then K is 1, 2, 3, 4, 5. And we're going to be over here at 5, K prime. K prime, the y changed, the x did not. The x changed, the y did not. And if we go ahead and draw the figure, you can see we have preserved size and shape. All right, so the rule for this one is reflected with respect to the y-axis. You change the sign of the x, you leave y alone. Let's go ahead and reflect across the y-axis. C stays put, 3 units here, 3 units to the other side, 1 unit here, 1 unit to the other side, and here we have our triangle. Over here, here's the line of reflection. C will go 1 unit to the other side, that'll be C prime. A will go over 2 units, this will be A prime. B will go over 2 units to the other side, B prime. And we have our triangle, and notice that the size stays the same, and size is preserved and angles are preserved. Let's take a look at this picture. It looks like this is a reflection, but it doesn't look like it's the x-axis or the y-axis. I want you to notice what the points look like. This is the x, this is the y, and K prime, this is the x and this is the y. Notice that the points have just changed their place. This is the x, this is the y, this is the x, this is the y. So x and y look like they have exchanged places. X, y, x, y. So let me go ahead and show you where that line of reflection is. Here's where the line of reflection is. It's right here. And this line is a line that's called y is equal to x. It's where the y-intercept is at 0 and it has a slope of 1, up 1 over 1, up 1 over 1. So this is a reflection with respect to y equal to x. Let's go ahead and do a reflection across the y equal to x line. So remember that the rule is to exchange this x and y. So this will be A prime and this will be 2, -2. Let's go ahead and graph it. A is 2, -2. So this will be A prime. B, remember this is X and Y, and I'm just going to exchange places, and that'll be 4, -2. So this is 1, 2, 3, 4, and then -2. And then this is B prime. And then C prime, this is X and Y, and we just exchange places, 1, 2. So this will be 1 up 2 over 1 up 2. Oh, this was incorrect. C was actually, let me erase this. C, I wrote this wrong, so this will be wrong. C is supposed to be 1, 2, and when we exchange places, this will be 2, 1. So we're going to go over 2, up 1. Here we go. And so let's go ahead and draw the line, and hopefully you can see that this is a reflection across the y equal to x line. Let's do it one more time. So A prime will be equal to -4, 2. So -4, 1, 2, 3, 4, and up 2. And that'll be A prime. B prime will be 2, 3 over 2, 1, 2, 3. That'll be B prime. And C prime will be -1, 5. So it'll be -1, 1, 2, 3, 4, 5, C prime. And so here's what it looks like. And let's go ahead and draw the y equal to x line to see if it looks like it's a reflection, and that does. So let's remember that a reflection is a rigid motion, and we use a little r, and we tell it right here, the subscript is what we're reflecting with respect to the line. And these are the 3 rules that we learned, one for the y equal to x line, x-axis, and y-axis.